Professor Ad here, and today we're going to write an equation of a parabola, given some particular features. Now, sometimes when you're asked to write an equation, you'll be given some different kinds of information. So in this example, we've been given a vertex and a focus. Sometimes you might be given a vertex and a directrix, or a focus and a directrix. The process may be a little bit different in the details, but broadly speaking, the process will be very similar in how you work through this. And what I like to do is I like to have a graphing space handy so that I can sketch out the information I know, and that will help me figure out the components that I need for the equation. So as you can see, I've written over here the pieces that I'm going to need to help me write an equation of a parabola. We'll need to know A, and then we'll need to know the vertex HK. And once we have those two pieces, we can write the equation. But for this example, I'm going to go ahead and do the whole graph just to give me some additional practice with graphing a parabola. So I'm going to start out by graphing the information that I know. And I'll also point out sometimes you won't know how big of a graphing space you're going to need. So I just did sort of a standard grid for me here to see, based on these numbers, it seemed pretty reasonable. So we'll see how this goes. So we've got a vertex at -3, 2. So I'm going to go ahead and plot the point at -3, 2. And we have a focus at -3, -3. So I'm going to graph my focus with an X here, -3, -3. Cool. Now, once I've done that, I now actually have all the information I need for the equation. But like I said, we're going to go through the whole graph just so we have that practice. But the reason I said we have the information we need is because this value of A is the distance from the vertex to the focus. So once I have those graphed, I can see I have that information. So I'm going to figure out what A is going to be. So we've got 1, 2, 3, 4, 5. A is 5. And HK is the vertex. So sometimes I pull that right from here. And other times I'm like, oh, okay, it's this one that I graphed. So we have -3, 2 for our vertex. So before I go ahead and write the equation, let's continue to graph the different components. So once I have the vertex and the focus graphed, I like to graph the directrix and the axis of symmetry. So the directrix is on the other side of the vertex from the focus. So in this case, because my focus is below the vertex, the directrix is going to be above the vertex. If the vertex, or if the focus had been like, if the focus had been over here, then my directrix would be a vertical line. So I think of the directrix kind of like the floor of the parabola. Oh, golly, what did I just do? So I'm just going to go ahead and A was 5, right? 1, 2, 3, 4, 5. So now I'm going to go up 5. 1, 2, 3, 4, 5. Okay, so in this case, it's kind of like the ceiling of our parabola. And you'll see why I said that once we have it sketched. All right. And let's make sure that's actually horizontal. Beautiful. All right. So the reason that I have that sketched is it helps me to remind me how this parabola is going to open. So conic sections like to eat up your focus. They take a lot of time. So when I graph my parabola, I know it has to go through this point, and it's going to be eating the focus. So it's going to open this way. Which means that this line here is kind of like this ceiling. It's hovering above my parabola. Or if this parabola was opening upwards, then it would be like the floor. It would be hovering below. So that's why I think of the directrix as like kind of like the wall that the parabola is not going to cross. Next, let's graph our axis of symmetry. So the axis of symmetry goes through the vertex and the focus. So this is going to be a vertical line running this way. And again, this is all just to help orient me so that when I sketch my parabola, I know where it goes. So lastly, the next piece I'm going to need for my parabola, I know that it's going to open in this manner, but I'm not sure if it's going to be a real skinny parabola or if it's going to be a really wide parabola. So I'm not really sure about that. So that's where the latus rectum comes in to help me graph the function, or in this case it'll be a function, but to graph the conic. So to do that, remember that all of the points on your parabola have to be equidistant from the focus and from the directrix. So my focus is living over here, and this blue line is my directrix. So if I want to think of this parabola opening in this manner, we see that it's going to hit some points along this line here. That's where my latus rectum is going to live. And to figure out whether it's really close to the focus or really far away, if I'm living here, notice that the distance from like this line to this line is going to be twice the distance as it is from here to where the vertex lives. In other words, I'm going to take this distance of A and double it. So if I double 5, I get 10. And that tells me how far away from the focus to plot my points along the latus rectum. So I have to go to the left and to the right 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm over here at 7, which makes sense since 7 minus -3 is 10. And then I don't think I have enough space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm over here somewhere. So I'm not going to graph the other point just because I'm off the grid space. So this would be a case if I were working through this with paper and pencil, that I'd be able to add some extra, vertical space for my graph, vertical grid lines, horizontal space for my graph to be able to plot that other point. But since we're working in Word today, we're just going to do the best we can. So I'm going to graph this so it goes through that point. And then, hello, we'll see how we can do. Hello, there we go. Is that too big? Oh no, it's almost perfect. There we go. So here's our parabola. Now, the graph that I'm using a piece of an ellipse here. So strictly speaking, this is not the right type of curve to be drawing, but it gets the idea across here as best as I can, given the tool I have today. So I'm just gonna contain myself to the graphing space here. But again, in a perfect world, I'd be able to graph that other point over here, and this would be going through it. And then just for demonstrative purposes, let's go ahead and graph the latus rectum, which runs through the focus, connecting those 2 points. Okay, so just to reiterate what I did here, I graphed the vertex and the focus. That gave me a distance of A. So to find the point on the latus rectum, it's kind of like you travel from the vertex to the focus A, and then you go in the, you take a 90-degree turn and you go twice that distance. So here we went 5, so I'm going to take a 90-degree turn and go 10 in either direction. That's how I get those 2 points on the latus rectum. And so now we can see that this green point is 10 units away from the focus, and it's 10 units away from the directrix. So that's what we really need it to be doing. So now that I have the graph, let's go ahead and create the equation. So an equation for a parabola, when I'm using the conic section techniques, has the shape something squared is equal to either a positive or a negative 4a times something. And remember that those somethings are going to be x minus h and y minus k. So those are the components I have. To figure out which component gets squared, I look at the way that the parabola is opening. So this is why having the graph can be really helpful. So this parabola is opening downwards. So this means if we were to think of it in the old way we were thinking of parabolas, that would make it a function because it passes the vertical line test. So because it's a function, that means I can be squaring the x. I don't want to be squaring the y. So that tells me the piece that gets squared is x minus h. And this other piece is going to be y minus k. So if this had been a sideways parabola, that would mean it's not a function because it would fail the vertical line test. And so I'd have y minus k as the component being squared. The way that this opens also tells me whether I have a positive 4a or a negative 4a. So this parabola is opening downwards. So that means it's opening in a negative direction. So we have a negative 4a. If it was opening upwards, then it would be a positive 4a. So this is the basically the template of the equation we need. So now we just plug in the values that we have. So a was 5. So actually negative 4 times 5 gives me a negative 20. H was negative 3, so this means I'm going to change this to plus 3. And y was 2, so we have minus 2. So there we go. That's going to be our equation of this parabola. X plus 3 quantity squared is equal to negative 20 times y minus 2. So that's going to wrap it up for this video. In the next video, we will be taking a look at an ellipse, and we'll be identifying the different features of an ellipse. So I'm looking forward to seeing you then. In the meantime, I hope you have a wonderful day, and bye for now.